Okay, so this is going to cover basically QTAG UID, quota 2, the idle timer, and well, we're going to also discuss why, well, maybe I think NFAct plus owner might not be sufficient for what we were trying to achieve here. So it started off in 2011, first quarter. NFAct was not available, and I had to deal with kernel 2635 for the platform I was developing on, and it had to work on that one. So I ended up looking around, and I didn't see anything that could have actually helped me. I looked into containers, namespaces. I looked at the other IP tables and netfilter modules, looked at the traffic controller, being able to handle things like TC indexes. And what we needed is to replace the UID stats that are in Android. Those actually require hooks inside the TCP stack to call into UID stats. Also, we needed to have traffic stats on a per device basis. We couldn't trust what's in ProcNet dev because it turns out that the device drivers that we're looking at either reset their counters at random times without never calling any of the net events. So there was no way to consistently ensure that for specific devices we won't go in over a certain threshold. And this was required because data plans for mobile phones started to introduce capping. In Europe it's very common, here less. So we needed to have a way to present to the user something that you could say, hey, I need to limit myself, and we needed to be able to track efficiently. Our initial implementations were good enough that some of the carriers turned to us and says, holy crap, you guys are doing it better than our own app. We're going to give up our app and then just use your stuff. We needed to be able to also distinguish, well, actually put blame on people who are using apps on services that are doing data usage. And one of the problems we stumbled upon was to be able to distinguish download managers. So UID stat is not just sufficient because it's going to say, hey, this is the system server or download manager, but actually it's some other app that's using the download manager to get something. So we needed to assign blame like that. And another one of the APIs that we wanted to do was to have the individual applications being able to say, well, actually, I open one socket, and on this socket, I'm going to do a whole bunch of things, but I need to be able to subdivide data usage on those different things. Things like maps would do tile prefetching, it will do authentication, it'll do user-facing tile fetching. And one of the features we were looking for was to be able to do traffic shaping in the long run. So we needed to have like the maps being able to say, well, right now I'm going to use this socket that's been open for the last hour and I've been doing stuff on the user. I'm going to use this socket to prefetch tiles based on your estimated destination. And that's one of the things that wasn't easily obtainable by just manipulating net filters and ownership. So it's, yeah, with net filters, you can say, yeah, I've opened a communication and right now I can tag it in a certain way or log against it. So what we wanted to be able to do is have this app quickly go in without having to go through all of the IP tables. One of the worries that we had was all the locking mechanism that needs to go around concurrent accesses to be able to change the rules in different tables. And so we needed a different API, similar to like quota 2 from the Xtable add-ons, that allows you to quickly read out a quota and actually reset it without having the need to go and look into IP table itself. It's got a procfs entry for that. Another thing we needed to be able to add enforcement. That's why we introduced the quota stuff. And third-party applications, we needed to be able to track all data usage, including applications that weren't cooperating with the system. So it's not like somebody opens up a socket and then says, oh, by the way, somebody in the Android framework, please add some IP tables rules for me because I'm doing something specific. So QTAG UID. Initially, Q standing for quota, but it turns out that I stumbled upon quota 2 that satisfied the needs that I wanted. And so I didn't end up implementing that. And the way QTAG UID works is it allows the sockets to be tagged. It keeps the data structure inside for each of the sockets that are open and tagged. And an application can go in and say, well, this socket that I have open, now I want you to tag it with a specific tag, and at that point, accounting all the traffics that go through the module will have counters associated with that tag for that specific socket. And that's the mechanism that the download manager uses. It opens up a socket that it's got a pool of sockets. Some of them stay open for a very long time. And suddenly now it says, hey, the music player needs to get an MP3. Okay, no problem. Download manager goes and tells the QTag UID module, by the way, this socket that has this FD, I need you to start counting against this other UID. Also, the QTag UID module tracks all of the interface statistics, and it keeps them persistent. Turns out that on mobile phones, the modem makers, they pop up interfaces and then they tear them down. Oh, you're changing from 3G to Edge, interface goes away, new interface comes back up, you're going back to Edge to 3G, and this is why ProcNet Dev didn't work for us, because we needed to be able to detect when interfaces went down. And these guys, they don't use net events to say, I'm tearing my interface down. They just tear it down, reset the counters. Or worse, they say they tear it down, but don't reset the counters, bring it back up later, and it's got the counters from previously. So the QTag UID module, instead, we hook it up in IP tables at the lowest possible levels, and it tracks for all the SKBs that come in. It stores them against the specific interfaces, and those are persistent, whether the interface exists or not. You can always go and query the QTag UID module and say, hey, give me my stats. And it keeps statistics at the protocol level as much as possible. So we talked a little bit about applications tagging their own sockets. Like Gmail can say, I'm fetching attachments. How much is that costing the user? As opposed to I'm fetching headers. And I'm fetching things in the background. And that needs to happen. It happens pretty frequently. There's also the notion of foreground, background. And we've got different sets of counters. QTag UID maintains them, and then the Android OS and Digo, they come in and say, oh, I'm switching you from foreground to background. Instead of having to go through IP tables and change some rules to say, oh, from now on, these counters are actually the foreground counters, QTag UID has a very simple interface where it's quite easy to just poke and flip the counters, and then you can flip them back. The choice of interface that we use for it is through ProcFS, because it was like one of the initial ones that we needed to have because we needed to be able to handle debugging. But we left ourselves the opportunity to switch over to either SysFS or IOCTLs or some other mechanism. And also QTag UID, as I said, it's replacing the UID stats of Android, which requires the hooks for TCP. Oh yeah, some things that didn't work, like Quota. The original Quota didn't support IPv6. So we ended up having to do some tweaks there. So that's basically covered. So these are some of the differences between the original netfilter modules and how we use them and how we've changed them. So these are now going over the changes that we need to deal with. Quota 2, it's, like I said, it's the Xtables add-on, initially checked in as is, and then the only thing that we added was sending up U events when we hit quotas. Why U events? Because most of what Android does in terms of networks, it's already got listeners in place for the U events. And so now when a U event triggers, it just sends out the quota, giving it the actual name and how it's hit. Quota 2 was interesting because it actually supports SMP. The quota that's currently in the kernel, well, okay, there was in the kernel back then, didn't support SMP because it kept its counters in per CPU stats. So you end up having these quotas that increment randomly. If you're lucky that all the SKBs come in on the same CPU, you're good to go. If not, it's a big mess. Quota 2 is SMP safe. Named quotas was interesting because we could name some of them like, hey, this is a warning for 3G, or this is a warning for LTE. And the framework that handles the connectivity manager can now know that it's reached a given warning quota. So U event, that's the only change. The XT idle timer, we use that to be able to handle cell interfaces that go down over a certain amount of time. The problem is the modem manufacturers, they do not advertise when their cell, the modem goes into low power mode. And it's the cell towers that tells the phone, oh, you can turn off your cell now. but the phone keeps a connection and the device is still up. So it's completely invisible to the user. The only thing that happens is if you send a packet, like after 5 seconds, you're going to put your modem back into high power. So we need to have something that would help user space say, well, okay, I'm going to kind of delay sending packets maybe for a few more seconds, just in case I've got more. Instead of sending one packet, waiting 10 seconds, sending another packet, now we wait 20 seconds, and then we send 2 packets, and we save on power like that. So we took the original idle timer, we switched again to U-Event, because that's the interface that we use mostly for networking stuff. And we needed another change on top of that is the one to track when the interface goes active again. Because as soon as somebody turns on the interface, or if the cell tower tells our phone, hey, you need to go to full power mode, we can start piggybacking on that event and bursting out small packets, saving power there.